Hello, my name is Andrew Schumann, and my talk is about the research context-based games of Physarum performance simulation model, fulfilled by the team consisting mainly of me, Krzysztof Pancerz, Marcin Group, and Andrew Adamatsky. This research is a part of the project Physarum Chip Project Growing Computers from Slime Mould, supported by the 7th Framework Program. Its leader is Professor Adamatsky, where we are going to study new mathematical tools for unconventional computing on programmable behaviors on Physarum polycephalum. It is a one-cell organism that behaves according to different stimuli called attractants and repellents and can be considered the basic medium of simple actions that are intelligent in the human meaning. Now we are constructing an object-oriented programming language which on the one hand simulates the Physarum polycephalum behavior and on the other hand shows which mathematical tools can be implemented in its behavior. In particular, it is possible to consider Physarum polycephalum simulation model for context-based games and behavioral finances. Notice that the Physarum polycephalum motions are a kind of natural transition systems, states, edges. The states is a set of states presented by attractants, and edge is a subset of a Cartesian product states and states. Is a transition of plasmodium from one attractant to another. The point is that the plasmodium looks for attractant, propagates protoplasmic tubes towards them, feeds on them, and goes on. As a result, a transition system is built up. Now, labeled transition systems have been used for defining the so-called concurrent games, a new semantics for games proposed by Abramsky. Traditionally, a play of the game is formalized as a sequence of moves. This way assumes the pairization of two-person games, when in each position there is only one player to move. In concurrent games, players can move concurrently. On the medium of Physarum polycephalum, we can first define concurrent games and second, extend the notion of concurrent games strongly and introduce the so-called context-based games. While in concurrent games we deal with a finite set of actions, in context-based games we can move concurrently as well, but the set of actions is infinite. This infiniteness is connected rather to non-well-founded properties of basic actions, in the meaning of Echel's non-well-founded set theory. They cannot be regarded as atomic so that composite actions can be obtained over them inductively. In other words, it is ever possible to face a hybrid actions which is singular, but it is not one of the basic simple actions. It is a hybrid of them. According to experiments with the slime mould, we can define the following three basic forms of Physarum polycephalum transitions motions. Direction. The plasmodium moves towards the attractant. Fuse. The two plasmodia fuse after meeting the same attractant. Split. The plasmodium splits in front of many attractants. Repellent. The plasmodium avoids the place of repellent. Let us consider the following thought experiment as counter examples showing that the set of actions for the plasmodium is infinite in principle. Assume that the transition system for the plasmodium consists just of one action presented by one neighbor attractant. The plasmodium is expected to propagate a protoplasmic tube towards this attractant. Now let us place a barrier with one slit in front of the plasmodium. Because of this slit, the plasmodium can be propagated according to the shortest distance between 2 points, and in this case the plasmodium does not pay attention on the barrier. However, sometimes the plasmodium can evaluate the same barrier as a repellent for any case, and it gets around the barrier in reach to attractant according to the longest distance. So even in the environment conditions change a little bit, the behavior changes too. The plasmodium is very sensible to the environment. Thus, simple action of Physarum plasmodia cannot be regarded as atomic so that composite actions can be obtained over them inductively. In other words, it is ever possible to face a hybrid action which is singular, but it is not one of the basic simple actions. It is a hybrid of them. In the transition system with only one stimulus presented by one attractant, a passable barrier can be evaluated as a repellent for any case. Therefore, the transition system with only one stimulus and one passable barrier may have the following three simple actions: pass through, avoid from left, avoid from right. But in essence, we deal only with one stimulus and therefore with one action. Also, this action has three modifications defined above. Simple actions which have modifications depending on the environment are called hybrid. The problem is that the set of actions in any labeled transition systems must consist of the so-called atomic actions, simple actions that have no modifications. Let us show that in the live world we face hybrid actions of human beings almost all the time. First, imagine a vending machine which dispenses items such as snacks to customers automatically, after the customer inserts currency. This machine is a labeled transition system with a finite set of actions of the following atomic actions: giving items which were chosen by the customer after they were paid, and giving change in case the price is less than the coins inserted. Now assume that we contact not the vending machine but a sales lady. Her hybrid actions in selling snacks and giving change can go with the following modes of modifications: smiling or not, talking or not, offending or not, being introduced or not, etc. The interval of possible modifications from typical actions to untypical is too large. So she is not a labeled transition system in its conventional meaning as a vending machine. The main difference from conventional systems is that we have no atomic actions of the sales lady. Therefore, her set of actions can be infinite, but it is impossible for conventional systems describing concurrency. The set of actions must be always finite and well-founded. According to our hypothesis, natural computations should be constructed on an infinite set of hybrid actions, which are built up on the set of basic simple actions that is always finite. We are going to design logic circuits for the unconventional computer on programmable behavior of Physarum Plasmodia as a kind of context-based games where hybrid actions for transitions are obtained on logic gates and or not. This approach in unconventional computing proposed by us is relatively new. In this approach, on the one hand, we consider the behavior of one-cell organisms as intelligent, and we want to obtain the new game theory on the basis of biological experiments, where fundamentals are defined on the experiments with one-cell organisms. On the one hand, we design logic circuits game theoretically, and these circuits can be implemented on the medium of behavior of different organisms, from parasites to human beings. In context-based games, we appeal to the following game theoretic assumptions. Each game can be assumed infinite, because its rules can change. Players can change their strategies, and the set of actions is infinite for each player. Resistance points for players are reduced to the payoffs if all actions are well-founded. For any game, there is performative efficiency when hybrid actions of players belong to the interval of expected modifications. We are going to propose an experimental game theory where on the one hand all basic definitions are verified in the experiments with Physarum Plasmodia and Bothamia utricularis, and on the other hand all basic algorithms are implemented in the object-oriented language for simulation on plasmodia. Some preliminary results allow us to claim that the slime mood can be a model for concurrent games and context-based games. In context-based games, players can move concurrently as well as in concurrent games, but the set of actions is ever infinite. In our experiments, we follow the following interpretations of basic entities: attractants as payoffs, attractants occupied by the plasmodium as states of the game, active zones of plasmodium as players, logic gates for behaviors as moves, available actions for the players, propagations of the plasmodium as the transition table, which associate with a given set of states and a given move of the players, the set of states resulting from that move. Andrew Adamatsky and Martin Group have performed promising experiments showing that there are cases when sets of strategies for players are ever disjoints. Let us suppose that we have only two agents. The first is presented by a usual Physarum Pacifium plasmodium, the second by its modification called a Badhamia utricularis plasmodium. Physarum Pacifium grows differently faster than Badhamia utricularis and overtakes more flakes at the same time than the latter. Only if the inoculum was fatal for Badhamia, it might grow faster. Moreover, if the invasive growth front of Badhamia is well nourished by oat, it easily overgrows the opposing tube system of Physarum. So, at the microscopic level, we can find out that in most observations, Physarum could grow into branches of Badhamia, while Badhamia could grow over Physarum strands. We can see that somehow Physarum feeds on small branches of Badhamia. Thus, in case of Physarum and Badhamia, we can observe a competition in the small branches. For them, the set of strategies are disjoint. They never meet the same states. On the basis of competitions between Physarum and Badhamia, we can study simplest biological forms of zero-sum games. In context-based games, we can't use conventional probability theory. The matter is that if we assume the existence of hybrid actions, then the entity of games are non-well-founded and therefore cannot be additive. The double-slit experiment with the plasmodium of Physarum is the best example of that conventional probability theory isn't applied for Physarum acts. Let us take the first screen with two slits which are covered or opened, and the second screen behind the first at which attractants are distributed evenly. Before the first screen there is an active zone of plasmodium. Then let us perform the following three experiments. First, slit 1 is opened, slit 2 is covered. Second, slit 1 is covered, slit 2 is opened. 3. Both slits 1 and 2 are opened. In the first, second experiment, protoplasmic tubes arrive at the screen at random in a region somewhere opposite the position of slit 1, slit 2. Let us denote all tubes landing at the second screen by A. Thereby all tubes that pass through slit 1 by A1 and all tubes that pass through slit 2 by A2. Now we can check in case of Physarum if there is a partition of set A into sets A1 and A2. We open both slits. Then we see that the plasmodium behaves like electrons, namely, it can propagate just one tube passing through either slit 1 or slit 2, or it can propagate two tubes passing through both slits simultaneously. In the second case, these tubes split before the second screen don't always occur at the same place. This means they appear to occur randomly across the whole screen. Thus, the total probability of A corresponding to the intensity of plasmodium reaching the screen is not just the sum of the probabilities of A1 and A2. This means that the plasmodium has the fundamental property of electrons discovered in the double-slit experiment. It is a proof of non-additivity of probabilities. Economics and conventional business intelligence tries to continue the traditional tools where reality is measurable and additive. And in statistical and econometric tools, they deal only with the measurable additive aspects of reality. They try to obtain additive measures in econometric studies of real intelligence behavior also. Nevertheless, there is always the possibility that there are important variables of economic systems which are unsurveyable and non-additive in principle. We should understand that statistical and econometric methods can be rigorously applied in economics just after the presupposition that the phenomena of our social world are ruled by stable causal relations between variables. However, it is not so. Hence, our study of context-based games on the medium of Physarum can make impact for many behavioral sciences: game theory, behavioral economics, behavioral finance, etc. Non-additivity of phenomena doesn't mean that they cannot be studied mathematically. There are some rigorous approaches such as periodic probability theory which allow us to do it. The most significant feature of periodic probabilities, or more generally non-Archimedean probabilities or probabilities on infinite streams, is that they don't satisfy additivity. On the one hand, the periodic analogies of the central limit theorem in real numbers face the problem that the normalized sums of independent and random variables don't converge to a unique distribution. There are many limit points, therefore there is no connection with the usual bell-type curve. In other words, in periodic distributions, we can't build up the Gauss curve as fundamental notion of statistics and econometrics. On the other hand, the power set over infinite streams like periodic numbers is not a Boolean algebra in general case. In particular, there is no additivity. We can't obtain a partition for any set into disjoint subset whose sum gives the whole set. Using periodic non-Archimedean probabilities, we can disprove Ullmann's agreement theorem and develop new mathematical tools for game theory, in particular, define context-based games by means of algebra and also cellular automata. In these context-based games, we can appeal just to non-Archimedean probabilities. These games can describe and formalize complex reflexive processes of behavioral finances, such as short selling or long buying. Let us suppose that the sample space of probability theory is not fixed, but changed continuously. It can grow, be expanded, decrease, or just change in itself. In this case, we will deal not with atoms as members of sample space, but with streams. The power set of this growing set can't be a Boolean algebra, and probability measure is not additive. We can consider Physarum behaviors within a certain topology of attractants and repellents as growing sample space. Assume that there are two neighbor attractants, A and B. We say that there is a string AB or BA if both attractants A and B are occupied by the plasmodium. As a result, we observe a continuous expansion of the set of strings. It can be regarded as a sample space of probability theory. Its values will be presented by periodic integrals. Let us show how we can build up the sample space of infinite product of omega constructively. Suppose that omega consists of p minus 1 attractants and AB are subsets of omega. Such AB are conditions, properties of the experiment we are performing. For instance, let A is attractants accessible for the attractant N1 by protoplasmic tubes, and B is neighbors for the attractant N1, etc. Some conditions of the experiment fixed by subsets of infinite product of omega don't change for different time t is equal 0, 1, 2, etc. Some other conditions change for different time t from 1, 2, etc. So we can see that the property B is verified on the same number of members of omega for any time t. Nevertheless, the property A is verified on different number of members for different time t. Thus, describing the experiment, we deal not with properties A, B, etc., but with properties infinite products of A, infinite products of B, etc. Let us define the cardinality number of infinite product of X as a subset of infinite product of omega as follows. It means that we have cardinalities for X for any time t, from t is equal 0, t is equal 1, t is equal 2, etc. Notice that if omega if cardinality of omega is equal to p minus 1, then cardinalities of infinite products of these properties will cover periodic integrals. The simplest way to define periodic probabilities is as follows. It means that a probability is equal to a cardinal number. Or, for example, another way. Notice that in periodic metric, the cardinality number of infinite product of omega is equal to minus 1. Adjunct knowledge structure is a function pi which assigns to each a from omega a non-empty subset of omega, so that each vote R belongs to one or more elements of each pi. This means infinite product of omega is contained in a union of pi, but pi are not mutually disjoint. The function pi is interpreted on periodic probabilities as follows. The double-slit experiment with Physarum plasmodia shows that first, we can't extract atomic actions from all the kinds of the plasmodium behavior. Second, probability measures used in describing this experiment are not additive. We can deal just with hybrid actions. The informal meaning of hybrid actions, this means hybrid terms or hybrid formulas, is that any hybrid actions is defined just on streams, and we can't say in accordance with which stream the hybrid action will be embodied in the given environment. It can't behave like any stream it contains, but there is an uncertainty how exactly. The hybrid action looks like the quantum bit, or qubit for short. Let us remember that a classical bit can't be 0 or 1. The qubit exists in various superpositions of 0 and 1 at the same time. There is an uncertainty of either 1 or 0, but qubit behaves like both 1 and 0. In other words, each quantum state is described in terms of classical states, associating two numbers with each, an absolute amplitude between 0 and 1, which when squared gives you the probability of obtaining the classical state when you measure the system, and a complex phase which governs interference effects. The classical states 0 and 1 are the top point and bottom point of the sphere, while the other states are in superpositions. The points around the equator represent states where there is an equal probability of measuring 0 and 1. As a result, we can represent the state of a qubit as simply the point on the surface of a sphere, known as a Bloch sphere. As a result, no matter what 2 points you pick, it is impossible to determine either of them by making a measurement on such a system. So, if the user sends such randomized states to the server together with measurement angles, there is nothing to be learned by any measurement of the system. Therefore, everything is perfectly hidden from a malicious server. In this same way, any hybrid action is a combination which is hidden from outside observers. The hybrid action includes as many versions of behavior of the whole system as possible. Thus, context-based games on the medium of Physarum Plasmodia can have many impacts in the development of conventional computing, from behavioral sciences to quantum computing and many other fields. Thank you for your attention. In case of any questions, please write to me directly. Thank you.